Hello and welcome back, fellow PowerShell engineers. We are now moving on to section 5. And as I noted in section 1, the original vision of the creators of PowerShell was to create a Unix-style way of managing Windows systems. And while we focused on this to a degree in the previous sections with file and directory manipulation, we have yet to examine how to manage things like system processes, services, disks, volumes, logs, users, and groups. Just to name a few things, anything to do with the system itself. And this is stuff, if you've taken a Linux class or you've worked with Linux or maybe got a Linux certification, those are the kind of things we think about, right? And say in like the Linux Foundation courses, right, for the Linux Foundation Certified System Administrator, if they still have that. I know those are the kind of things you start off with. Moving around in the directory, some of the stuff we've done. So while we're bouncing around in this course, we're kind of doing programming stuff, system stuff, user stuff, AI stuff. It's a lot of stuff, but it's important to remember that this is kind of what PowerShell was originally meant for. And these are some core things that PowerShell can do. And there are actually really, really important things you would want to automate with this, and that you could use ChatGPT or other AI tools to generate code for. So, all right, guys. Let's go ahead and move on and get started with this section. All right, welcome back, fellow PowerShell engineers. We're now going to talk about the Get-ComputerInfo commandlet. And let's go ahead and open up our PowerShell window here. All right, and if we wanted to look at our computer info, we would just type the Get-ComputerInfo. It's loading quite a bit of information there. You'll notice all the different things that this gives you. Totally fantastic. And of course, it gives you other properties that you can dig into a little deeper. Your different network adapters. I mean, all sorts of things here. Your domain controller, boot state. I mean, really just a whole boatload of things. The BIOS release data, interestingly here, you'll notice that that's kind of wonky because of the fact that this is a virtual machine. So, yep, I'm on the evaluation edition. So, like with all of our information that we get with a PowerShell commandlet, we can also set that to a variable. And now that we've got that here, we could get the, say, the OS architecture, boot device. I was thinking version, but you get quite a lot of different things. Maybe I'll go a little further. Oh, the prevention stuff. Wow. That is a lot of stuff. Just wanted to get the OS version. There we go. And a little bit of a page reset there. We'll see our version number there. You can also get at this stuff through the pipeline. So for some reason you didn't want to set a variable, use the select object commandlet, a property parameter, and then we could get our version there. So if we wanted the time zone, there you go. You got your time zone, right? So again, this, I like to show the variable thing because I'm thinking in terms of scripting, but also in terms of scripting or just getting diagnostic information. So you don't want to go through this real quick and you know what you're looking for. You can do that pretty easily. So that's about it for Get-ComputerInfo. This is a super valuable tool for auditing systems that are in your network. It would be great for something like assessing systems for the purpose of a hardware refresh cycle, assessing systems for security updates, or just areas of concern for performance. Maybe you think you're having performance issues and you can use this to audit the amount of memory or disk space available in a system or a series of systems, right? you could do that remotely. So that would be very useful. Or say, what if you had a upgrade that you were performing on all of your systems, and you wanted to know, hey, is there enough? Did that memory actually get? Did those hard drives get pushed out there? Did that happen? Do we want to audit? Maybe there was a machine we missed, right? If you were auditing, doing a lab, or all of the secretaries in a building, or that kind of thing. So a lot of use cases. You guys could come up with the use cases, I'm sure, for all the different fields that different spaces that we work in with technology. So that's about it for the section. Let's go ahead and move on to the next one. Hello and welcome back, fellow PowerShell engineers. We're now going to take a look at how we can look at system processes with PowerShell. And the way we do that is with the get process commandlet. And we can just type get process, and there we go. We get our processes. And we can see a variety of information here. The ID, the number of handles it's using. We get our process name. We've also got things like our non-page memory and our page memory. So some other things that memory usage and CPU usage, right, of the processes that it's giving back. So we can actually format, or we can actually filter, this. We could format this different. Actually, I'll go ahead and show that. You can just pipe that to a format list if you wanted it in that format for some reason. Either way, just always like to point it out. Hey, don't forget the pipeline. But you can actually look at the filtering piece just by doing a name parameter. So see, we can filter. We've got our task manager process running. We could also filter that by ID. So if we do get process ID, and I don't know, we can just pick WinLog on up there. We see the ID there, 540. Of course, you could set this to a variable to look at it more thoroughly, but I don't really think you need to do that. And then lastly, you can actually filter just by specific properties. So say you didn't want all of the page, non-page memory, blah, blah, blah. You can pipe it to format table or format list. But then you can filter by the properties, as we've done before with other things. So you just want the name and the ID. There you go. Name, ID. Again, all these might be useful in a script where you're monitoring specific processes, and you only need a certain amount of information, right? It's possible you're doing performance monitoring and need this stuff, but it obviously depends on the use case for all your scripts. And that's about it for the get process. That's how you view your processes. Again, you can kind of do this graphically with Task Manager. I'll go into details. You're getting some of the same information you'd be getting there, right? But of course, the idea would be that you'd be programmatically doing something with PowerShell. So that's about it for this lesson. We'll see you in the next lesson. Hello and welcome back, fellow PowerShell engineers. We are now going to go over how to start a process using the start process commandlet and also stopping processes after that. So this commandlet allows you to start a process by specifying the path to the executable file for that process. So say we wanted to start Notepad.exe, we would just use start process. And we'd specify our file path. Which will go to Notepad.exe. And let's go ahead and give that a start. Boom, we see that we've now started the process without issue. You can also specify additional parameters for the process, such as the working directory parameter. And that would allow you to specify the working directory for the process. You can also specify an argument list parameter. And that would be if you were starting it with some different arguments. I can't really think of a good example of that, but certainly if you have a custom exe that you're passing arguments to, you would want to use the dash argument list parameter. But to turn around and stop a process, all we have to do is use the stop process commandlet. People are sometimes critical of how verbose PowerShell can be, but this is pretty straightforward, right? So we do a stop process with the name notepad. Down here that it has killed our notepad process. So you can also use the force parameter to stop a process. So that would just be dash force. Actually, just give this a run. See, if it can't find it, it won't open it. But we can reopen it. And let's use the, use the force, stops it. Might be useful if you were using this in some type of security issue, or if you were trying to kill a process, and maybe you couldn't get to Task Manager. I can think of some machines that are loading so slow that even Task Manager won't load. If you can somehow get into a PowerShell session, that might be useful. Or if you're just killing processes for other reasons, right? You might be doing a sort of auditing check routinely, like, hey, certain processes shouldn't be running at certain times. You could kill them with a force. Or if you've got a process that's got a memory leak, this might be useful. Generally recommended only to use that as a last resort, though. If a system is crashing, as mentioned, or a memory leak, that kind of thing is going on. So that's about it. We'll go ahead and see you in the next lesson. Hello and welcome back, fellow PowerShell engineers. We are now going to look at how we can view system services. You could probably almost guess what that commandlet would look like at this point. And by typing get-service, we see all of our services. We can actually see the status of each service, whether it's stopped running or disabled. And we've got the name and the display name of the services, right? So I believe disabled would be in there. Maybe just stopped and running. Not seeing any disabled services. So with that, we can also, like searching through our processes, we can use a name parameter. If we want to find our print spooler, we would see that that's running. And note too that that's using the display name. We can also look up just the regular name using that name parameter, which is pretty useful. So, of course, you can use both. You can also, just like we did with processes, you can just format those or get the specific properties. You could format those as a list. I think a table is more useful in this case, so we'll just leave it as a table. And we can get our status. Just want our display name and our status. However you'd like to do it too. Obviously, that looks a little bit better. It depends on how you'd like to organize the data. If you're just looping through, or just depending on how you just want to see it, I guess. Another thing you can do is, and this is where we get more into like what's the actual useful use here, is we can filter whether or not it's running, and we can do that with the where object. And we'll use our PS item variable, and then we'll do the status, right? And an equal, operator, and we can look for our stopped. And we could turn around and look for our running. Get all of our running services. And we can also turn around and look for our disabled services, which I don't think that there are any. So that is about it for just viewing our services. Let's go ahead and move on to the next lesson. Hello and welcome back, fellow PowerShell engineers. We are now going to look at starting and stopping services. And to do that, we will use the start-service and the stop-service commandlets. These commandlets allow you to start and stop by specifying the name of the service, real similar to what we've already seen. Unfortunately, when you run these commands, they really don't give you any feedback inside of PowerShell. I mean, if you're just in the console anyway. You were doing this, you're like, okay, hey, did it work or what? So, but to go ahead and see that, let's actually do stop-service first. We'll stop our print spooler service. And a way to validate, to just go check out our services is of course, the services. See, and if we go look, there we go. We see that it is not running. And of course, we could do that with PowerShell too, with the get service. And we would see our print spooler. Oh yeah, it would be under spooler. Spooler is stopped, right? So that way it's probably a better way to get to that through here, because we actually get the actual status of it. Whereas obviously this implies that, right? But it doesn't actually say stopped here in our UI. So just something to note. And of course, we can go ahead and restart it with the start service equals, and let's just use the spooler name. Again, we can alternate back and forth. If we go back here, we'll actually have to refresh the view. I clicked on that right there, which refreshed it. And it doesn't refresh the status right here. You'd have to almost close and reopen that. And this is another thing that's a little frustrating too. It's just organized differently. We see that it's running, right? So, and again, we can go here, and we can actually, don't have to get all of them. We see that our spooler is running. We restarted it with a start service. Now, if you wanted to just restart the service without doing even two commandlets, you do have the restart service commandlet. And that go ahead and that will restart that. And again, no real feedback there. It would let you know if it failed, however. But pretty useful if you just wanted to restart your print spooler. Gosh, not a big fan of print servers and print spoolers. I'm sure most of you guys can relate to that. If not, I don't know. I'm sure everybody can relate to who the heck is a fan of print services, right? It's something common. I've seen it implemented. Just this is a scheduled task or a scheduled job to help ensure that the print spooler just runs correctly on a print server. Or two, I mean, if you're clearing out print jobs on a machine, this might be really useful rather than getting in the UI and hunting down for this. It's like, hey, just remember restart service. It can't get much more simpler than that. And you only need to use the name. You don't even need to use the display name. So if you've got access to a PowerShell window, So PowerShell, you're good to go. So, all right, guys, that's about it for this section or this lesson. Let's go ahead and move on to the next one. Hello and welcome back, fellow PowerShell engineers. I am now going to delve into how to look at drive volume information. You can use the get volume command for that. And let's go ahead and give that a go. See how well this does here on our VM. Yep, pretty sweet. So, we've got our drives up here, our drive volumes, our system reserved. And then we've got, I assume that's swap. I don't know what that is. And then our core volume here. And then it's picking up our volume for our CD-ROM, which is mounted virtually with Oracle VirtualBox. And it's pretty good table here, too. It gives you your size remaining. It gives it to you in megabytes or gigabytes. This already kind of calculates that. But we can also use the drive letter parameter to get our drive volume, or to get our volume information. So let's do drive letter. Let's just take a look at our C drive. As we can see, we just get our C drive. Now, as you can see too, the table doesn't, it's a little wide there, so we can actually pipe that to a format table. Sorry, a format list. And now we get even more volume information than we did. We've got all of our object information here, but we get a lot more volume information. You'll note too, when you do this though, it's not going to give it to you in gigabytes, which is okay because actually PowerShell has the ability to do arithmetic in gigabytes. But before we do that, let's just take a look again. I just have to show this. Or just to reiterate that, we can get at the data different ways. So we can do get volume, and then we could do, let's actually do a drive letter C again. And we'll pipe that to a format table. And we'll just get some specific properties, namely drive letter. Although if we're just doing one drive letter, I guess we can know that. Label, and we'll do size remaining. All right, pretty cool. We got our information there. I guess we didn't need label. I don't have a name for that disk yet. That's all right though. So let's go ahead and do, let's put this information into a C drive variable. And now let's take a look at it as an object. Right, there's our information in bytes. As I noted though, we can divide that by gigabytes. And now we've got our information in gigabytes. So pretty cool that it's able to do that. We could actually just turn around and do that as megabytes. And we could do it as terabytes. I mean, you can do it however you'd like it to be formatted. And that's actually what I do. I know I keep bringing this up throughout this course here, but what you can also do is in my format or my disk cleaning script, let's go over here and go to my GitHub. Go to, disk cleaner. Again, available in 109 different languages. And we'll take a look at the PSM file. So I'm dividing it right here. You can see that I'm dividing it by 1 gigabyte to when my function returns the amount of junk found, the junk removed, or junk not removed, it is returning that in gigabytes. And I'm actually using the math here to round it to 2 places, right? So that avoids the issue of like, hey, do I really need all of these place values here. I don't think so, right? We could do some rounding here at some point. So we just go 2n on that. So just want to make you aware of that. Definitely go check out my disk cleaner script. If you want to see some more of how we work with PS Drive. I mean, PS Drive is actually the foundation of the disk cleaning script. And it's how we're getting information about the volumes and cleaning up, then I do some things to clean them up. And then we are returning those values so that the end user knows what was done to clean the disk or what was removed and how much was actually removed. So definitely pretty cool. Hate to say it sounds so wonky, but yeah, I love PS Drive. It's a great commandlet. All right, guys, we'll see you in the next lesson. Hello and welcome back, fellow PowerShell engineers. We're now going to show you how to empty the recycle bin using the clear recycle bin commandlet. It allows you to delete all the items in the recycle bin, or you can use the drive parameter to specify a specific drive to delete the items that you found. Let's go ahead and actually make sure there's something in our recycle bin. There's not. So I'm going to make a quick file here. Close that out for now. Pop something in there. Got something in our recycle bin. The new text document that has 0 kilobytes. All right, let's go back to our PowerShell. Let's go ahead and just do a clear recycle bin. Back a tab, complete that, and I can. All right. Are you sure you want to confirm? Are you sure you want to perform this action? There's a little confirmation there. Just say yes. And we go check our recycle bin. We see that it's empty. Again, we could specify the drive letter, as I noted in the introduction. So we could actually do, if you had multiple volumes, drives that you wanted, whoops. Oh, man. Oh, no, it's just drive. Excuse me. Still stuck on PS Drive mode, right? So let's go ahead and make another file there. I'll do an A this time just to switch it up. And we see that it's gone. And I want to do one more demonstration with clearing the recycle bin. I know it seems super straightforward, and it really is, because by virtue of PowerShell making it super straightforward. So let's go ahead and put that there. I'm getting a little tired of that confirmation, right? So let's just go ahead and do a force. No confirmation this time. It's emptied. And that's actually how we do it in my disk cleaner script. I do a force and we specify the drive letter in that. So pretty cool. Yep, that's about it for this lesson. Let's go ahead and see you in the next lesson. Hello and welcome back, fellow PowerShell engineers. We're now going to take a look at how we can utilize both AI and automation to leverage PowerShell to get things done for ourselves, systems engineers, right? So what I want to do is just have it make a simple scheduled job that will automatically clear the recycle bin at midnight every night. So a PowerShell script that will schedule the here recycle bin commandlet to be run every night. When you're doing these two, sometimes I've seen it where it picks a scheduled task instead of a scheduled job. So it's important to specify if you want a scheduled job or a scheduled task. So we'll say with a scheduled job. So I had a little bit of a typo in there. All right, so let's read what it actually says. Certainly, here's a PowerShell script that schedules the clear recycle bin commandlet thrown every night at midnight using a scheduled job. So we've got a script block that's got the force on there, so that's interesting. And then it defines a scheduled job with the job trigger, the action, which would be the script block, and then it registers the scheduled job. So the script creates a scheduled job named clear recycle bin job, triggers daily at midnight, and then runs the clear recycle bin commandlet with the force. So we can save it and run as a PS1, but we don't really need to do that, right? Because we can just sort of register it anyway. So let's just copy it and run it as administrator. I've seen this happen before with the scheduled jobs, where it says the job trigger does not match. So what we can do is just let ChatGPT know that there was an error here. It seems to be doing this because I think I've seen this actually in some of the other videos I've already made. So let's give this a shot now. Let's check to make sure it didn't already make the job. So we can see which ones we have here. All right, so it already did. So let's do the unregister schedule job. Cycle bin job. And we should see that that's gone now. So let's go ahead and give that a run again. It registers no problem. So if we just take a look, whoops, just do the get scheduled job. Did I type it correctly? Only human. All right, cool. We see it there. Looks like I maybe already had one here to name that from before, based on that ID. Because I see it was before my ransomware scanner jobs that I've made in some different lessons. Also, guys, too, yeah, on these, I'm using different VMs and stuff all the time. So I've got a couple different virtual boxes, and then I've got sometimes I'm doing stuff in AWS, but it doesn't matter. But anyway, I'm just throwing that out there. So we see that it is there now. So now we have a job in 4.5 minutes that's going to run nightly to clear the recycle bin, which is definitely something that could be super useful in a system environment or a desktop environment even. So pretty cool. Now, what I want to do next is let's start a new chat. Build a service controller with Windows Forms. All right, to be able to have a start, stop, and restart button. And we'll do it for the print spooler service. Definitely, I don't know if you've seen with end users. Potentially, they may have issues depending on their drivers or their printers or whatever. And this is something I always go back to. We had joked about selling this, some friends and I, calling it print magic. But might not still be a bad idea, I guess. But to me, it's just such an easy PowerShell script to make. So let's go ahead and get it going. Write a PowerShell script. See what it gives us. Pretty cool. Looks good. We see it's creating it's getting the assembly type. Let's go ahead and load PowerShell ISE. And let's give it an open. Restart, stop, restart. I don't really like the way it did that. Let's see what it does here. Further service is stopped. It's restarted. We can also go ahead and verify in the services app. Checking the status as we're doing this. Idea why I would make these buttons like this is just kind of weird. Let's do stop it, and we'll do. Yeah, see, if we just hop off of it and back on, we see that it stopped. We can do our restart. See that it's going again. Stop. Start. Just verify all our buttons work here. So that's pretty cool. Again, just built a service controller like that, like nothing. You could actually use ps2exe to make that an exe file that you could deploy out as part of a package, or package that even into an MSI installer. But I do want to have it try to clean up those buttons. I'll make the buttons all spaced out evenly and the same size. So again, making Windows forms without, and you'll see I'm actually on this server I'm logged in is a free version of ChatGPT. I know I've used my paid version in some other ones. I think it was just because I forgot that I was logged in here, but I was like, hey, let's give it a shot. I didn't want to re-log into the other one because the free one, quite frankly, does work just as well for the most part. It's just a little bit slower. You don't have access to GPT-4, right? So, all right, let's give this a shot. Ooh, that kind of messed that up. Let's just say undo that last change. See what it does here. You can really just see how much slower this loads versus the Pro version. It's really clicking at a slow pace. But still, pretty incredible for being free. It's moving a little too slow for me, so I'm just going to go back and get it the way it was. And we can actually just fix this ourselves. Let's go ahead and squeegee that. So, again, I don't know why it didn't make buttons the same size. So we have our start button. See, this is 100 by 30, 100 by 30, and then they made this one 150 by 30. So that's all I really wanted. Did over 120. So then this one moved it down for some reason. So again, this is our XY. So we do this 30, and then we can do. So we look at the difference here between 30 on the X to here. That's 90. So I would add another 90 to this. just a spacing thing. I've just done this a little bit. And now we're going to have 30 plus 100. Let's just make this 400 wide. And it takes a little bit of knowledge to do this, but not really. Boom. Start, stop, restart. 400. You could make that even a little smaller. Maybe 380. All right. Looks pretty good. And we know it works. And again, these system logs too, these are all logged in the event viewer, so you can go see when these services are stopped and restarted. So you now have a spooler controller that you can run. Just give you could give this to an end user to restart their spooler themselves if they were having a frequent issue. Maybe want to get a better printer or figure out whatever real issue's going on, but this would be something to help out in case you had to do that. So again, we're looking at 13 minutes in this, and we made a scheduled job and graphical user interface for a service controller using AI. So, and we've both of those would solve real problems. So, I love it. It's quick, it's easy, it's PowerShell, it's good stuff. So, all right, guys, we'll see you in the next lesson.